Okay, so imagine this. You've got to manage the data for thousands, maybe even tens of thousands of farms. We're talking every single farmer, every crop in the ground, every price fluctuation at the market. It's a huge amount of information. How in the world do you build a system that can not only handle all of that, but also... So what you're looking at right here, this is the answer. This is the architectural blueprint for a platform called AgriFIMS. And yeah, I know, at first glance, it looks pretty complicated. And, well, it is, but it's also a really smart solution. It's designed to be the digital nervous system for an entire agricultural region. And that really gets to the heart of what we're talking about today. How do you actually build a digital nervous system for farming? How do you connect all these different people, all these different processes, and all this tech into one single system that actually works? Well, that diagram we just saw, that's our roadmap, and we're going to walk through it piece by piece.
So here's how we're going to tackle this. First, we're going to start with the people on the ground with a day in the field. Then we'll climb up to get a bird's eye view from the control tower. After that, we'll pop the hood and check out the engine room, figure out where data lives, and finally, we'll see how it all plugs into the wider world by connecting the digital farm.
All right, let's start this whole journey not with databases or code, but with the people who make this entire system possible. The ones who are the real foundation. We are heading out into the field.
So, let's meet the main character of this whole story, the field agent. This person is the crucial link, you know? They are the human connection between the dirt and the data. Seriously, without them, none of this works. No information gets into the system. They are absolutely essential. So, what does a day in the life of a field agent actually look like? Well, they're out there meeting with farmers, getting them registered in the system. They're capturing the precise GPS coordinates for each farm, super important. And they're even uploading the latest price data from local markets. They are literally the eyes and ears on the ground, collecting all that raw data that fuels everything else. Okay, so we've got data coming in from the field. That's great. But now we have to zoom out a bit. You can't just have everybody seeing and doing everything, right? That would be chaos. So let's head up to the control tower and see how the system manages who gets to do what. The whole thing is built on this really clear pyramid of access. See, at the very bottom, you've got your casual visitors who can see some public info. Then you've got partners and our field agents who have very specific jobs. Moving up, you have a state admin who's got oversight for a whole region. And then, right at the very top, you have the system administrator who basically holds the keys to the entire kingdom. It's all about making sure people only have the access they need. Now, this whole concept has a name. It's called Role-Based Access Control, or RBAC. It sounds kind of technical, but it's a really simple idea. Just think about a big office building. Your visitor key card might only get you into the lobby. An employee's card gets them to their floor, but the building manager's key card, that one opens every single door. RBAC is the exact same thing, but for digital information. Simple, right? And this shows you that difference perfectly. A state admin has a pretty powerful job, right? They can manage their team of field agents and pull all sorts of reports for their region. But the system administrator, they're on another level. They can actually change how the system itself is configured and manage every single user account. Different roles, different levels of power. So we've got our people on the ground and we've got a clear set of rules for who can do what. Now for the fun part. Let's pop the hood and see the engine that makes this whole thing go. Welcome to the engine room. See this block right here, the one labeled backend? This is the absolute heart of the AgriFIMS platform. The diagram calls it distributed microservices. And I know that sounds super technical, but the idea behind it is actually really cool and intuitive. This is where all the real work, all the heavy lifting gets done. So what in the world are microservices? Well, instead of building one gigantic, messy program that tries to do everything at once, you build a whole team of small, independent, specialized programs. Each one has just one job, and it does that one job perfectly. Think of it like a professional kitchen. You wouldn't have one chef trying to bake the bread, grill the steaks, and make the dessert. That'd be a disaster. No, you have a pastry chef, a grill chef, a sauce chef. Each one is an expert. That's microservices. And here are a few of those chefs from our digital kitchen. You've got a user service, and its only job is to handle logins and permissions. Then there's a farmer service that just worries about farmer data. You've got a market service for prices and a reporting service for making all those charts and graphs. Each one is a specialist, which makes the whole system run way more smoothly. Okay, so all this data is getting collected by agents and crunched by the microservices, but where does it all live? every good system needs a library, a place to store all its knowledge. So let's go check out the bookshelves.
Now, you might notice something interesting here. This platform doesn't just use one database. It uses two totally different kinds, PostgreSQL and MongoDB. And that might make you wonder, why would you need two? Well, it turns out it's because not all data is shaped the same.
So here's the deal. PostgreSQL is for what we call structured data. Just think of a perfectly neat spreadsheet where every single row and column is clearly defined. It's perfect for things like farmer contact info or market prices. MongoDB, on the other hand, is for unstructured data. Think of it like a big, flexible filing cabinet where you can just toss in anything. Photos, random notes, PDFs, you name it. The system is smart enough to use the right tool for the right kind of data. All right, we've covered the people, the security rules, the engine, and the library. There's just one last piece to this puzzle. How does this digital farm actually talk to the rest of the world? A system this important can't just exist in a bubble, right? And this blueprint shows it doesn't. It connects to the outside world through things like SMS text messaging, so it can communicate directly with farmers. And it also has these integrations with external APIs, which is just a fancy way of saying it can talk to and share data with other important systems. It's built to be a team player. And here we are, right back where we started, looking at the full picture. But hopefully, looking at it now, it makes a whole lot more sense. You can actually see the journey the data takes, from the field agent, through the secure platform in the middle, getting processed by that microservice engine, stored in the perfect database, and then connected out to the wider world. Every single piece has its place. So, if you're going to remember anything from this blueprint, make it these 4 things. 1, it's all built around the needs of real people. 2, its security is smart and layered. 3, its engine is made up of efficient specialists. And 4, its data storage is flexible. It always uses the right tool for the job. These are the big ideas that make a complex system like this actually work. And that leaves us with one final big thought. A blueprint like this, it's not just about wires and code. It's really about what's possible. It makes you ask a really interesting question. What does the future of farming actually look like when every single piece of data, from the soil on one farm to an entire country's market prices, is all perfectly connected?